Mr. Mark Fly, to talk about understanding air conditioned heat pump ratings. Mark, how you doing today?
I'm doing great.
Good. Well, we're glad to have you. Let me get some screens here situated. And again, if you're watching, just the all the links are below to your PDH certificate. If you're watching this in the future and you're on, let me see here, YouTube or our podcast, just check out the show notes, and you have my email address in there, and you can email me at that time. So so I've known Mark for quite some time. Mark has been a frequent guest on our YouTube channel and podcast, talked about many topics. I don't think we've done this one yet, so I'm looking forward to this one. This is one of those that's it seems like I should know everything about this, but after 20 something years, I'm sure I'm going to learn a lot today. So it's one of those kind of things. And I know we got a lot of questions in the industry. So Mark, why don't you take a minute, introduce yourself, and take it away, man.
Okay. So I'm Mark Fly. My title is the executive director of the Norman S. Bjornson Innovation Center, which is the laboratory at AHRI. That was kind of because that was my last pre-retirement job. And my current pre-retirement job, because we can't come up with a good title for it, is I'm a paid DL. So 2 days ago, I was in your Nashville office doing some seminars for Hobbs in Nashville. So
and we appreciate it.
And talking at ASHRAE meetings. So that's kind of what I do. And this presentation is one of my DL lectures, one of my ASHRAE distinguished lectures that I give. And it's so I'm an old guy. I've been around a long time. I have lots of stories. So I will try to keep my stories down to an hour.
You can hear a lot of them on our YouTube channel, by the way.
Yeah, I know. And then on everything I say, Tony turns into sound bites for the next 3 years. So.
That's right. Yes. Be careful when you come on the show. You never know what's going to happen.
Yeah. You always pick out those things that, did I say that? Yes, I did. So.
Awesome.
So you ready for me to start?
Yeah, go for it. Whenever you're ready, my friend.
Okay. So really this is this is about what unitary air conditioning and heat pump ratings are, but it's a little bit of a history lesson, because I always like to understand where things come from and how the sausage is made. So there's a lot of how the sausage is made part of this. I'm not going to teach you how to calculate a variable speed SEER rating, because I don't know that I could do it anymore. But but I can tell you kind of what they are and what's important on them. So so basically we're going to go through the certified ratings and where they come from, and how complex this has got in the last few years since DOE has entered the picture, and the interaction between all the different parties that go into making and setting these energy levels when they come up every year. So, or every 3 years. So, we love acronyms in HVAC, and the U.S. government loves acronyms. So, ASHRAE used to be the American Society of Heating, Refrigeration, and Air Conditioning Engineers. Now we just call it ASHRAE because we decided we didn't want to just be American anymore. But there's a lot of different organizations in here. And so the first one I'm going to kind of talk about is the ASHRAE part of this. So ASHRAE's been around a very long time and been developing standards. And the thing I really like about being involved in ASHRAE and the way they go about things is these are truly consensus standards, which means it's not made by manufacturers. It's not made by consulting engineers. It's not made by government officials and code inspector people. The standards that come out of ASHRAE are developed through the ANSI standard, ISO and ANSI standards process, which means you have to have balance in those committees, and they are thoroughly reviewed processes, and so that they're really in depth as far as how the standards are made. And one of the things that a lot of people don't know that when ASHRAE puts together a standard, they part of that process is they put it out for public review, and some of that stuff that ASHRAE sends you all the time, if you're an ASHRAE member, says, hey, such and such a standard's out for public review. Well, you can go review that standard if you make a comment, that committee has to respond to that comment. They don't have to agree with it, but they have to respond to it. So I can remember, years and years ago, they were working on a standard on environmental tobacco smoke. You can imagine how popular that was. Because people in casinos and hotels back before smoking was not hardly allowed indoors anywhere. So they were trying to figure out how to make a standard for that. And so they got 100,000 comments on that standard. So they didn't, that standard never happened, right?
Right.
Because no one was going to be able to respond to 100,000 comments. But that's the good thing about it. And so what ASHRAE does is it develops the method of test. It decides what temperatures, what kind of tolerances you have to have, what kind of facility you have to test equipment. So and these are really consensus standards, which means that they have broad acceptance. It's really made by the HVAC community at large, with all the parties represented. So very, very, very precise and accurate. The next player in here is AHRI, and AHRI is the listing agency. Been listing equipment for over 60 years. So it's more than 300 manufacturers around the world basically list equipment. Now, AHRI is a trade organization, so I don't belong to AHRI. I'm active in AHRI. My company Aon belongs to AHRI. So no individual belongs to that. So they also make standards, and they typically make the listing standards. They decide how many tests you have to do to certify a product, and how often do you have to retest that product, and how do you keep those standards, trustworthy and accurate over time. But because they are an industry trade organization, they don't have the broad consensus. They don't have all the parties at the table all the time to do that. So they are following the ASHRAE stance. So basically, what we say is that AHRI develops the listing standards. How do you determine that your product meets a certain level? And ASHRAE says, well, how do you test it to get there? And really, the most important part is how you test it. So,
hey, Mark, I'm sorry to interrupt you.
Yeah.
I think Courtney and Heather, I think we're offline. I think we have to refresh the browser. Hey, we handled that like a couple of pros there. So anyway, we're back live. I hope you all could see us. So continue, Mark. Sorry about that.
Okay. How far do I need to back up? Do we know?
I think you were good on this slide. I think it was really just the last minute there. I think we caught it right at the cutout. So
all right. Well, get some of the things out of my screen here.
Yeah, take your time. We were talking about AHRI.
Yeah. So like I said, AHRI is a trade organization. They do the listing standards, and they have for years had an agreement with ASHRAE. And so prior to 2013, when DOE entered the picture, then it was kind of AHRI and ASHRAE would get together, and every time a new standard of 90.1 would come out, AHRI and ASHRAE would work together. And as you go, Tony, I always tell student groups there's only 24 people in the HVAC industry, and we all know each other, so it's a very small group. So you go to the AHRI committees, you go to the ASHRAE committees, it's the same guys a lot of times, or a lot of the same people sitting on these. So there's a lot of crosstalk between these. So there's been a good understanding, and, and even coming in Chicago, AHRI, ASHRAE, the show, the big annual event for equipment every year is co-sponsored between those organizations. So
okay, interesting.
So it's a long-term standing relationship. So like I said, they've been around since 1888. Started out basically as an organization of ice machine manufacturers who got tired of the biggest liar wins, and decided that they needed some standardized way to measure performance of ice machines. I don't know why Zoom keeps popping stuff up on me. Um, um, uh, so, and then, since 1953, they've been the Air Conditioning and Refrigeration Institute. Since 58, they've been certified unitary air conditioners. So, long time,
Mm-hmm.
long history. So, so there are two standards in HRI that are the listing standards, the 210, 240, and the 340, 360. Those used to be different standards. Somehow they got combined. They put that slash, but kept both numbers. And coming soon in the future years, actually, there's going to be a brand new standards because a lot of these metrics are changing. I'll talk about that in a little bit, but a lot of that's going away. So basically, 210, 240 is what DOE calls residential, what the HRI calls unitary small. It's anything under 5 tons, anything under 65,000 BTUs. And that's the product that's rated in SEER. So it's about 80% of the HVAC market's under 5 tons, and it's dominated by residential equipment, most of that being single phase residential equipment.
85%.
Yeah, some I don't know the exact number, like but it's 85%. Some huge amount of the equipment sold in the world is residential equipment, just because there's so many houses compared to how many commercial buildings there are. So 340, 360 is the commercial side. That's anything from 5 tons, basically up to they call it unitary large, and then unitary very large, up to 760,000 BTUs, which is about 63 tons. So above 63 tons, even though in our business, that doesn't seem that big, because the companies that I represent and the stuff that your companies represent sell a lot of equipment over 63 tons.
Mm-hmm.
The amount of equipment sold in the market is relatively small, so that's kind of where the cutoff point for certification of products is.
Gotcha.
So, and both of those standards basically use that ASHRAE standard 37, which is the method of test. How do you actually test the equipment? So along comes DOE, and basically along with DOE is NRCan, which is the Canadian version of DOE, and they are the national listing. And basically Canada tries to, because of the close relationship between us and Canada, and we ship a lot of equipment across the border going both directions. They try to keep everything aligned. But in 1975, Congress passed the Energy Policy Act, some EPCA or EPAC. I've heard it pronounced both ways.
Mm-hmm.
In 1975, that is the law that created the U.S. Department of Energy. And it also created basically the ability of the U.S. Department of Energy to regulate HVAC products or any energy consuming products. Now, when you go to DOE and talk to them, they call our HVAC units appliances. That always annoys me, but they regulate appliances and
like irons and washing machines.
Like irons and washing machines. So in EPAC is a list of products, a very long list of products that they can regulate, and air conditioning in there, and fans are in there, and compressors are in there, and light bulbs were in there. That's the reason you can't buy an incandescent light bulb anymore. It's why if you buy a new washing machine, it doesn't dry the dishes a dishwasher, it doesn't dry the dishes, or the dryer doesn't dry your clothes. The newer equipment's much more energy efficient, which means it's probably uses a lot less energy. So sometimes it takes a little longer to do its job.
Well, the most efficient air conditioner is the one that's off, right?
Right. The most efficient air conditioners are the ones that's off. So in 1975, DOE had the ability to regulate all these products. Well, it took them a little while. It actually took them to 2013 to get around to air conditioners. They were too busy doing electric motors and dishwashers and refrigerators and light bulbs. So, so it really wasn't until relatively recently in the whole scheme of the history of DOE that they've actually regulated air conditioners. So and so when they did that, I've said earlier, which you turned into sound bites on different YouTube, the compliance division, the first time I met them were about a dozen lawyers and one engineer and some bureaucrats. So, they don't have a lot of technical expertise, especially in the enforcement compliance division. So typically what they do is they rely on industry, which is good. They rely on industry trade standards. So they copy and paste into the Federal Register, making it federal regulations or federal law, basically, the standards from AHRI and which reference back to the standards for ASHRAE. So every 3 years, EPAC, once they've started regulating a product, every 3 years, U.S. Department of Energy has to look at that energy efficiency of that product and decide whether it's good or whether they need to bump up the efficiency. And of course, they rarely decide that it's good, and they almost always bump it up, right? So basically now, if you look at ASHRAE 90.1, which sets the minimum efficiency standards for products, which we say is the standard of care or good practice to those have to be done with DOE and HRI. So this process has got really complicated to actually make a change. The other thing that happened because of HRI, because of DOE, is in EPAC is a clause that says there is no backsliding. So if you make an energy efficiency, if you say the SEER has to be 15 SEER, next year you can't decide that 14 SEER is okay.
Can't go back.
You can't go back. So that's caused some problems recently because, this year in January 2023, they wanted to change some of these test procedures and change some of the listing standards because, and so that would have caused the energy levels to go down. So that caused some problems, which we'll talk about here in a minute. So I've been really involved in a lot of this. I've been in ASHRAE since 1982, even though they say 1985 because I missed paying my dues one year. It's in 1984 apparently, but no matter. I've been involved in a bunch of things in ASHRAE. I haven't been involved in 90.1. I know a lot of people that are. I always said I've stayed on technical committees. I've stayed off of standards committees. I tried not to get involved in the standards as much, but then I got involved in HRI and I got involved in a lot of standards. So, but I've been doing that really since 2006 for intensely, I guess, or putting a lot of being there. And I've been on the board director. I've been on the board of directors of both those organizations, and right now, I'm a member of the. I was a member of the Unitary Leadership Council, which is kind of the head oversight committee for unitary equipment. Right now, I'm on the Applied Leadership Council. So just recently, they put me on there. So, and then DOE, I was at that negotiated rulemaking in 2013 when we first started regulating air conditioners because. Being lawyers, they decided to change a couple of words in one of the standards, and I calculated that AON was going to have to test 9 trillion units per year. Because
I remember you talking about that. Every filter, every different pressure drop, and
a good friend of mine who was also on that committee said, "Hey, I'm he was one of the mainstream manufacturers. He says, "Hey, I figured we've got 12 million and you do more custom stuff than we do. So I think you did your math wrong." And I said, "Dick, does it really matter? I mean, 9 trillion, 12 million, 15 trillion. It doesn't really
not
matter.
happening either.
It's not happening. There's, It
I
just
got a
isn't.
question, Mark. I'm always
Sure.
curious about this. How does it work? Like, let's say the DOE has some new whatever initiative or person there that's saying we want 30% improvement in commercial HVAC in 12 months. I mean, do you guys just say, sorry, we can't do it? Or how does that? Because obviously that's an unreasonable leap. Does that ever happen? And how does that process work?
Well, a lot of this happens, and really what happened in 2013, that was the first negotiated rulemaking. So
Okay.
prior to that, um, and HRI was really the watchdog because ASHRAE being, there's a difference in the types of corporations that HRI and ASHRAE are. ASHRAE cannot lobby because of the type C corporation they are,
Oh, okay.
so they don't lobby. That's part of their
Hmm.
bylaws. They're part of their not for profit or nonprofit. I don't remember which one. HRI is the other one. They do lobby. so
Okay, gotcha.
we have, we can go up to the hill and we can talk to people. And um, so because of that, ASHRAE is reluctant to go out and sue the federal government because they don't like something they're doing.
Gotcha.
HRI, on the other hand, as a representative of all the HVAC industries, we don't have that problem. so
Right, right.
so up until before 2013, you know, DOE would come out and they have to justify every time the U.S. government puts a regulation in, and a regulation is basically all those departments under the Constitution exist because of the Commerce Clause in the Constitution. So it's about interstate commerce. The only
Hmm.
reason the federal government has any ability to make regulations is because of interstate commerce. They have the ability to regulate interstate commerce. If you were going to build the air conditioning and consume the air conditioning and never move it across the state line, then I guess DOE couldn't really tell you what to do in
Oh,
theory.
interesting.
But
Huh.
that's so they are agencies under the administrative branch, under the president, um, and they have to put laws together, and there are rules around how they put these together. They have to put out a notice of a proposed rule, and they have to publish it, and they have to go out for public review, kind of like the ASHRAE standard process.
Hmm.
And they have to respond to. But what used to happen before 2013 is then HRI would sue them, and they had
Hmm.
government lawyers, and we had corporate attorneys because we had more, because we were corporations, and we had better lawyers than theirs, and HRI almost always won. so
Hmm.
they were getting really frustrated because they were trying to do what they considered their job, and they're listening to a lot of different, there's a lot of different constituents. There's also
Hmm.
a bunch of organizations that are trying to get energy advocacy, the Sierra group, all the environmental groups, they're all talking there. And so DOE was having trouble getting what they wanted to get done without getting sued, and they kept losing. So they went to the Department of Transportation and they said, "Hey, you guys pass these miles per gallon CAFE standards all the time, and we know that we're dealing with these podunk HVAC guys, automotive guys. They're even that's even a bigger industry, right?
Yeah.
With even better lawyers."
Yeah.
so
Yeah.
uh, so so how do you guys get those miles per gallon? How do you keep advancing and getting better efficiency cars all the time? They said, well, we do this negotiated rulemaking, and so this negotiated rulemaking process, and actually the in 2013, the guy that was the facilitator for this uh, negotiated rulemaking process was from the Department of Transportation. They had him come over and
Gotcha.
oversee it. So
Showed them how it's
basically,
done.
they get about 25 people together, and there's you
Hmm.
apply and you send in your resume, and um, there's a bigger group called ASHRAE. I can't remember. There again, a bunch of acronyms, right?
Hmm.
But there's a bigger group, and so they put a negotiated rulemaking group, and everyone on that negotiated rulemaking group signs a paper when we start that says, if we all come to consensus agreement on this, we won't sue you. and generally the trade association is involved in that too. So HRI is on there, and so it kind of breaks down into, you know, 2 or 3 teams is what really happens. Is you get some energy advocate guys, uh, uh, usually some people that are the guys that are asking, hey, we want to be 50% more efficient next year, not really knowing what that means or what it takes to do that,
Right.
you know, but that's what they'd like to do.
Yeah.
uh, you've got the manufacturers who say, well, you know, what can we practically do, what can we get done and actually accomplish, you
Hmm.
know, without being overly burdensome, without cratering the whole HVAC industry, because everybody still wants to buy air conditioners, you know.
Right.
So we got to do something that we can get done, practically get done. And then sometimes there's some, and then usually there's some end users, you know, maybe big corporations or some other representatives, facility people from some customers, you know. So these 25 people all sign this agreement, and then about every other week for 3 or 4 months, we go to Washington D.C., sit in a windowless conference room in Washington D.C. and argue about, you know, the difference between hot gas reheat and hot gas bypass. And
Oh my gosh.
it's a yeah, it's and come up, take this rule, tear it apart, put it back together until everyone signs. At the end of the day, you sign this agreement. Basically, you come up with what they call the term sheet, which is all the major parts of that regulation that we've all agreed to. And you know, it's like any kind of good negotiation, everybody's equally unhappy. So,
Yeah.
but
Yeah. Yeah.
it's not a bad process. It's an interesting process to see how that sausage is made.
Yeah, for sure.
And that was the very first one there, and that covered HVAC, water heaters, boilers, and commercial refrigeration. So we had a bunch of guys there, you know, the people that build glass freezers in grocery stores, and the HVAC guys, we don't even know each other. We've never talked.
Right. It's like
So
completely different
it's a
industry. Yeah.
completely different industry.
Yeah.
You know, sometimes we talk to the like gas furnace guys, but the hot water people we don't talk to, and we don't talk to the boiler people. So it was
It's
it
so
was
funny.
it was very interesting process to me to be in that room, you know. And as Tim
I'm
Wentz,
sure.
who was one of the ASHRAE presidents a few years ago, you know, his theme was you have to be in the room. And so there's a certain amount of,
Yeah.
you know, it's always good to be in the room and see how this is made. So
Mhm.
so that's kind of how I got involved in it. So, you know, like I said, ASHRAE makes that method of test, how we test the equipment. HRI does the listing standards. ASHRAE then, along with HRI, um, come figures out what is the, see if I can,
Yeah. Take your time.
yeah,
How it works together in the US. Look at all that stuff.
yeah. So, you know, HRI and now and also the Canadians. We talk to we're talking to Canadians, and US DOE and the Canadian and Intercan work pretty well together.
We work good together. We're not like constantly fighting each other. And
They're not constantly fighting each other. They tend to Intercan Canada tends to add things on, and
mm,
they add things on about export across the border, and
mhm.
you know, they check things going across the border to make sure that it's happening, at least
Yeah.
going that way. And I'm sure we check things going this way, but since I don't build anything over there and ship it over here, I don't know about that. But you know,
Right.
we get stuff stopped at the border occasionally because it didn't quite have all the things that they thought we ought to have.
Mhm.
You know, and
Yeah.
if you've dealt with building inspectors, you know, it's like you know, every building inspector interprets things just a little bit different. So
Mhm.
so that kind of happens. So basically, they all get together, and so before we can change those levels in 90.1, basically we all have to agree how that's going to happen. The other thing that happens is, since it's every 3 years, a lot of times there are things in the standards that we found problems with in the last revision. It's like any standard, as you start using it or start testing it, this doesn't quite work real well. You
Mhm.
want to tweak this or tweak that, and now it has to go all the way through the process through all these different agencies. So basically, most of the HVAC industry complies with, but DOE has the big hammer. So DOE can can stop me. Basically, they have the authority to regulate manufacturers. So they will come out and say, hey, in January 1st, 2023, you cannot sell a 3-phase piece of under 5-ton equipment with a SEER into this certain area less than 15. You cannot manufacture that piece of equipment and offer it for sale in that area.
Mm-hmm.
And if I violate that as a manufacturer, they have all the power that the IRS has. They can fine me.
It's a big deal.
It's a big deal. They can fine me. They can fine me so much per day for every unit I ship, or they can even come in at some point. They have the authority to come in and padlock the doors, just like the IRS.
Wow.
If you don't pay your taxes, they can shut you down, right?
Mm-hmm.
But it's civil. In Canada, it's criminal. So it's interesting. So no, the director of engineering for AON does not, and I was the director of engineering for AON at the time, does not get thrown in jail in the US for violating this. But in Canada,
wow,
it can be criminal. So there again, that's one of those other little tweak things. At least that's what I've heard. But anyway,
yeah.
So most of us, so to comply with that, AHRI basically has a method that they've been using for 60 years. Every year we test 20% of our basic model groups, and that's how many categories do we test from. That was the thing that DOE messed with back in 2013 that got everybody's attention. They redefined basic model groups in AHRI for unitary equipment. Basic is compressor capacity plus or minus 5% and condenser coil square foot area. So for all practical purposes in a given model, it's a tonnage. So if I have whether I have a digital compressor or a variable speed compressor or a 2-step compressor, if they're all within 5% of capacity, they can all be in the same basic model. And then AHRI will pick at random from your offerings and tell you exactly what to build, whether it be variable speed or whatever, anything you have a different energy efficiency for. And you test those in an independent lab to make sure that you are correct. And you test them and they have to be within 5%, or you fail and you pay a big fine. And if you're under the federal, and so every day AHRI ships off or syncs their database to DOE. So if I fail a test and it fails below that 15 SEER, DOE knows about it, and then you get to go talk to them. So AHRI tests a lot of equipment. It's very expensive to belong to AHRI for a manufacturer. They get a percentage of your sales, actually. It's a small percent.
Really? I didn't know that.
It's a small percent, but it's a percentage of your sales.
Gotcha.
So the more you sell, the bigger the company is, the more you sell, the more you do, the more you pay AHRI. So there's lots of testing involved. DOE is testing everything from light bulbs to refrigerators to air conditioners. So the odds of you actually getting tested under the DOE regulation, and you can just list with DOE. You can go in and list directly with DOE, but most manufacturers, because we want to do the right thing and because we need that structure of forced testing every so many years to make sure that we keep everything current, most people list with AHRI, and that automatically lists you with DOE. It's just that as a government agency, DOE can't say you have to list with AHRI, because AHRI isn't part of the government. That would be a monopoly, and they can't create that.
Yeah.
You could start Tony's listing agency next week, and you could strike the same deal AHRI has with DOE if you want to do that. So
yeah, if you guys want to give me a percentage of all your
give
sales,
a percentage sales,
I'll take it.
You'll take it, right? But so that's what that certification standard is. AHRI 210, 240 does up to 5 tons, 340, 360 does up to 760,000 for some products. Water and evap cooled equipment goes up to 250. Heat pumps go up to 250. So there's some limitations, like water source heat pumps only go up to 11 tons. So there, historically have been different ranges, and that's part of the thing that gets discussed all the time with DOE and AHRI and ASHRAE. And 90.1 has listings above that, but they're not getting tested. because they're not in the
Mm.
certification program. And part of that is that, there is a limitation to how big a laboratory you can build. And if there isn't enough market in there, it's not worth building there are basically, in the US, there are 3 testing agencies that do all the testing for AHRI and DOE, the independent testing agencies. Underwriters Laboratory, UL, ETL, which is Electrical Testing Laboratories, part of Intertech. Used to be Edison, used to be Thomas Edison's company, Edison Testing Laboratories, and Canadian Standard, CSA. Canadian,
CSA, okay.
Yeah, so CSA also does testing. Canadian Standards Association does testing. So those 3 people do almost all the independent testing for everyone. And there's just for them to build a new laboratory to test a 300-ton unit,
Right.
it's just not there's no payback for them.
Right.
They can't there's no profit, there's no payback.
There's just not a lot of them. Yeah.
There's just not a lot of them. So, so basically DOE copies 210, 240 and 340, 360. We as the industry always watch them really close because they want to change a few things and, and make sure that, goes through and goes in there right, and then every 3 years they are revised by federal law. So the thing that's happened in 2013 is, up till that point in time, to list with HRI is voluntary. So even though a lot of jurisdictions said that you had to have listed products, we want if you're bringing something into my city, we want to be sure that people are telling the truth and it's the right efficiency. There was no federal law that says you can't do it. Now there is a federal law that says I can't offer it. They say the term they use is offer into commerce. So I can't offer it for sale unless it's listed in the DOE database. And so, like I said, most people do that. So I kind of talked about this, about that update. You can self-certify to DOE. You can go online. Most people use the HRI database because it's easier to look at. There is a national DOE database for equipment. It's hard to search and hard to find things in, but it is there. And you can list directly there. Because they can't mandate that you do anything else. So like I said, 20%. And typically anything up to 20 tons, for HRI certification, you build 3 samples. So I build 3 units. They come in and say, I want to test that one. They randomly pick among the 3 that you test, and then you ship it off to Plano, Texas, where there's a UL and an ETL laboratory, or Cortland, New York, where there's an ETL laboratory, and they test it and make sure that it meets that requirement. Those labs are ISO 17025 qualified labs. And basically, if you fail that test with HRI, there's a $10,000 fine. They publish on their website, this product is relisted. That's not, my marketing people really don't like it. They say, hey, I cheated and I relisted this product. Like I said, the failing test is the easiest way for the chief engineer of a organization to lose his job.
Oh, it's that serious. So
it's the salespeople really don't like it if if your listing says, hey, I had to revise this. And if you fail any point in that test, any of the things, you have to re-rate everything in that basic model group. So if I fail a digital compressor, I have to re-rate my variable speed down by that percentage, however much I failed it by. So it's a big deal. And that's why all manufacturers have laboratories and do a lot of testing. Because it's very important that we know what our equipment does.
Right, because what you spit out on paper usually doesn't happen in the real world sometimes.
So in 2019, the annual budget for HRI was $20 million to test. The annual budget in that same year was $10 million for DOE, and that was testing everything from light bulbs to air conditioners. So just for air conditioning, we were more than twice what they were at that time. So So let's kind of talk about what we're listing. What are these metrics? So for unitary equipment, 210, 240, there's EER. Under HRI, we have EER, SEER, and HFPF, which is for heat pumps. And now it's SEER 2 and HFPF 2 for single phase. And I'll talk about that here in a minute. For bigger equipment over 5 tons up to 63 tons for the most part, it's EER, which is full load capacity, IER, and IER and SEER are both part load. They're basically weighted averages at part load conditions. And then in 2029 for IER, there's going to be a new metric called IVEC. And if for heat pumps right now, there's only a full load COP at 47 degrees. That's the only listing point, both federally and in HRI. But there's going to be a new part load in 2029. And you were asking about, how quick. I want to do it next week. A lot of these things get, those new standards are written now, but it's going to take till 2029 because it's completely retesting everything in the industry because the standard's that much different. So basically it's out 2 cycles. There was a 2023 cycle. There's going to be a 2026. We're going to go up in efficiency. And then in 2029, we're going to have these new metrics. Got it. And so the U.S. Department of Energy, but the U.S. Department of Energy by EPAC can only regulate one thing. So DOE requires that you have capacity, SEER, EER, and IER, so they can regulate as many as they want. But in DOE can only regulate one metric. And for a long time, they just regulated full load power. And one of the things that we did in 2013 was talk him into going to SEER. I mean, they did SEER for residential, but for commercial equipment, it was just EER. Now they regulate IER, but they can't regulate both. In HRI, you have to meet both. Whatever you say is EER and whatever you say is IER. So they had to pick one, and that's what they picked. Generally, most engineers think, well, I want to know the part load efficiency because our equipment never runs at full load. But if you talk to people from utility companies, they're really concerned with what the full load capacity is because they want to know how many amps is this going to draw on the worst day, because that determines how many power plants do they have to build. So the utility people are always really concerned with EER. So EER, which is the basis of all these things, is basically the cooling capacity in BTUs per hour divided by the watts. So it's just cooling capacity over watts. So it's kind of an efficiency. If it was a percent efficiency, it'd be cooling capacity in watts divided by watts. And so if you go over to Europe, they talk about, watts per watts as a percentage, but it's just, we use BTUs per hour being ugly Americans, and we still use British thermal units, even though the British don't use them.
We're hanging in there, baby.
We're hanging in there. And, when I was in school, we were going to change the metric system. I'm still waiting. So, 40 years ago, it would have probably been easier, but, that's not where we're at. So, right. So, and both of those are measured at 95 degrees Fahrenheit, dry bulb, and 75 wet bulb for outdoors. And then the indoor condition on both, on all these are 80 degrees and 67. So that's kind of a mixed air temperature because all these tests just look at the return air coming into the coil. You have an indoor room and an outdoor room. The outdoor room, you keep at 95, 75. The indoor room, you keep at 80, 67. And that's kind of the equivalent mixed air with some amount of outside air. And it's probably not right anymore because we use more outside air. And we don't have fluorescent ballast heating up the plenum anymore. So, so I don't know that those are the right numbers anymore, but that's what we test at and always have. And if you go changing any of these, that changes the efficiency, and that might make your EER, IER go down, which would cause problems if you couldn't get to where you needed to be. So seasonal efficiency ratio for 5 tons is SEER. And, SEER products, because of the size of the volume of units sold in that residential market, which is enormous, the people in SEER do a lot of testing. And basically the tests are run at 95, 82, and 67 outdoor dry bulb temperatures, and they're weighted between the two. And there's a different calculation if it's multi-step, if it's just an on-off compressor. But typically the heaviest weighting's at 82. So if you have an 82 degree outdoor test that's very, very efficient, unit that runs very efficient at 82, you'll get the best sear. So the other thing, if it has to cycle a compressor to hit any of these load points to run at 67 outside and 80, 67, if you got to cycle the compressor to maintain capacity at that point, then they have a cyclic factor, and you can either test that cyclic factor, or you can or you can either test for it, or you can take the default. The default's 2. So what that really means is that the default factor is if I have to turn a compressor off and back on, it's going to cost me 20% of the energy basically to bring it back, turn it off and turn it back on. So there's a 20% loss to do that every time you have to do that. So now when you actually test it, it's never that bad. That test has a lot to do with re-evaporation of the water that's on the evaporator, or when you shut it off, then all the water that's on the evaporator goes back into the space, so you have a negative latent load capacity while that's going on. And then when you turn on, you have to get the refrigerant moving. And when you actually do the test, you can do it 5 times, get 5 different numbers a little bit. It's a little bit of a random number generator. But kind of the best I've ever seen is like 0.09. And the worst I've seen about 0.18. So somewhere between 10 and 20% is probably the right number for what it's actually going to cost to cycle a compressor. That's why, when we talked about earlier in one of our other programs, we talked about different compressor technologies. That's why variable speed or digital are so much better. If you can keep that compressor running and not have to cycle it off, it's way more efficient. So, and then for a heating season, you've got HFPF for unitary small, 62, 47, 35, and 17 if it will run there, and 5 if it will run there. So, basically there are some conditions where that equipment may not run. You may block it out. You're just going to go in electric resistance heat. And the indoor temperature is 70 degrees and 70 dry bulb, 60 wet bulb for the indoor return air temperature during the heating season. And there again, that 47 degree test is if you get a good 47, you get a good HFPF. And then generally at 47, you don't have to do defrost. So that's one of the kind of interesting things about heat pumps is the ratings are all weighted heavily for commercial equipment. It's all at 47. It's just basically the COP at 47. And even with HFPF, it's heavily weighted at 47. The one condition that you do not have to turn defrost on. And defrost is a efficiency killer.
Oh yeah.
For a heat pump. So because it's kind of like that cyclic factor. You're losing a lot when you have to go into defrost.
Yeah.
And there again, there's another 20% if you have to stage compressors on and off to meet that capacity. Okay, so IER is the energy efficiency ratio for stuff above 5 tons. It's way simpler because it's 100%, 75%, 25%, or 50% and 25. And then at 95, 81 and a half, 68 and 65 degrees. And then these are the weighting factors. And there you can see 23.8% is at 50%. 61.7 is at 75%. So 75% is the heavy weighted factor on that. And, I don't feel terrible about that. I've been in lots of buildings. If you go into a commercial building, and a lot of chillers and air handlers, if you go inside and walk up to in a fan room in a commercial building and look at the VFD, it's usually running right around 75% when the building's occupied. There is a lot of hours there that run about that load. But these are kind kind of artificial at one set of weather conditions. These are not numbers that you can put into an energy program and actually figure out how many BTUs per square foot per year your building's going to use. It just gives you an idea when you're comparing brand X to brand Y.
Mm-hmm.
And then coefficient of heat pumps is just heating energy in watts divided by heating power in watts. So for a heat pump, typically the COP is greater than 1, because you are pumping heat out of the outside air. So you're getting more energy, heating energy out than you're putting in. If you have electric resistance heat, the COP is typically close to 1, because all that energy going into that electric resistance heater is being turned into heat into the air inside. So that's why people like heat pumps, because they do have a COP better than 1. They're up 3.5 at 47 degrees. So you're getting 3.5 times more energy than you're putting into it in heat at 47 degrees. As we look at low ambient heat pumps, that COP goes down as you get colder and colder because there's less heat out there to pump. So, but it's usually still, even at 0, it's 1.8, 1.6, 1.8 kind of thing. So it's better than just electric resistance heat if you can get your equipment to run. So the ASHRAE 90.1 and the DOE regulations kicked in this year, January 1st, 2023. You'll see another round in January 1st, 2026. See another round in January 1st, 2029. And what happened this year is the energy level got up, especially, really for all the equipment. It went up enough that it almost eliminated single step on off compressors. So if this was a big deal for the residential market, if you have a residential air conditioner that is still using a just on off compressor, you have an enormous condenser. That's the only way you can meet this. And it's just ragged edge because it's almost to the point of diminishing returns on this. So to meet those efficiencies, to meet that good 82-degree load point, which is kind of like a 75% load on a house, you're going to start seeing people put more 2-steps or variable speed equipment in there. And certainly in 2026 and in 2029. So and the other thing that happened in 2023 is the static pressures that are measured are extremely low. And they've been that way since AHRI started testing this. And it's a little bit embarrassing to be part of the industry, but this is where they are. And the next chart will show you where they are. So what happened in 2023 for residential only, because this was negotiated with DOE, for single phase equipment only, they raised the external static on things under 5 tons to 1/2 inch external, which is about right for a residential application. So, but when they did that, it basically made it extremely difficult with a 1/2 inch external. That was too much energy, and you couldn't meet that 15 SEER anymore. So they had to implement, because of this new backsliding rule, we had a dilemma. They wanted to raise it up, change that test standard, test it to more regional static pressure, but it was going to make the numbers go down, and the federal law didn't allow that. So the DOE lawyers came up with this brilliant idea. They called it SEER 2. And because it's a different metric, the number can go down. So it's a loophole in the law, basically implemented by the government lawyers.
Yep. We did a presentation on that, and to folks who are not in the engineering side of it, and it's just so confusing.
Yeah.
It's so hard to explain why that is, but anyway.
So these are the static pressures, the standard static pressures. So, a 5-ton unit was tested at 0.2 inch external, which is very low. A 63-ton unit is tested at 0.75 inches of static. And for 3-phase equipment, these still all apply. The static's going up for residential. This went up this year. In 2026, it'll go up for commercial. Both those standards are being rewritten, and they're going to include more fan energy, and they're going to take into account economizers and heat recovery and some of the other things that 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 aren't taken into account now. So it's a completely different test standard, and they're raising these static pressures up, 3 or 4 times what they were before. So
gotcha.
So it's going to be a better standard, but it's going to be a brand new metric. And for big equipment, for all this big equipment, that's going to be out in 2029. The other thing on SEER is regional standards. So it's hot, wet, southeast, hot, dry, southwest, and cold climates.
Mm-hmm.
And one of the kind of interesting things are, because part of that, if you think about the industry, if you're a person that builds residential units and you're selling them to distributors and they've got them in a warehouse, and then all of a sudden January 1st, the standards change and you can't offer them into commerce, that's a bit of a problem, right? I've got all these pieces of equipment that don't comply. And so in the Southwest and Southeast, they said, okay, we're going to let you have to comply. If you got it in your warehouse, you can't install it after January 1st, 2023. But if you got it in the warehouse, you could ship that up north and we'll let you install it, because that's based on date of manufacture, not date of install. So now what really happened in January 1st, 2023, nobody had anything in stock because of supply chain shortage. So it really didn't matter. But this is one of those negotiation things that takes place among, this is where the manufacturers went to DOE and said, we just can't do that. We're not good enough to time this to not have anything in stock, especially in the small residential stuff.
Right.
So these are the numbers. So the top number, and there's the north, the southeast, and for AON, we kind of pick southeast because we do a high select, because I don't want to get involved with people bootlegging units from Minnesota into Texas. because in the north I could have a 13.4 SEER, but in the southeast I have to be a 14.3 SEER 2, or I have to have a 14 SEER in the north, but in the southeast I have to be a 15. So from AON standpoint, when we look at these, we always say, hey, we're just going to build equipment that meets the worst case scenario, so I don't have to pay attention to where I build it for. But you can build it you can have different efficiency levels that maybe you can't sell everywhere.
Right.
So especially so there are these regional standards. For the large equipment, what's coming in 2029 is this IVEC and IVHE. And actually, Kevin Tiekle of AON, who I know and you've probably had on your podcast at some point, he's really proud of these because he was on this committee, and I think he actually invented these acronyms. So Kevin's really proud of it. So I know he was very much involved in this. And so the static went up 2 to 3 times. It's also looking at economizers, which was one of the things that we've always just kind of ignored. So it's looking at a lot of different things. They're also looking at, they're working on a new standard for the small stuff, they're going to look at off mode power. So how much energy does your crankcase heater take when the unit's off? You said nothing's better than off, but if you've got but you may have a crankcase heater that's keeping the oil warm. So yeah, it's really efficient. It's not using much power, but it is still using power. So that matters. So there's a lot more things in these new standards that they've spent a lot of time, and we're getting a part load efficiency metric for heat pumps, which is long overdue. So how are we doing on time? We've been talking for a while, but
it's okay.
I'll kind of wrap this up. So I'm going to talk a little bit, and I've got some pictures. Actually, these are my psychometric chambers in our lab. So these are the ones I've got familiar with. So this is a picture of what we typically call an over-under chamber. If you build roof equipment, over-under chambers are good. So the upper chamber, the floor in between is kind of like the roof. The upper chamber, we put a box around it and we create weather in there, and we can make it 95, 75 up there, or whatever temperature it needs to be. Or, in our chambers, we go down to minus 20 in those chambers
Wow.
upstairs. So that's how we've developed that 0-degree heat pump that AAON has now. The downstairs chamber is kind of boring because it's usually kept at 80, 67 today, but I think that will probably change under the new standards. So part of what has to go on is everybody has to make sure they're equipped, their standards and their equipment. So you put the equipment in there, you have an indoor room and an outdoor room, and you run that equipment. So like I said, you go into this is a big unit going into one of our big outdoor rooms. And once you put that in there, you hang these sampling trees. These little PVC pipes has a bunch of holes drilled in it.
Mm-hmm.
And so when I say it's 80, 67, or I say it's 75 or 95, 75, I have to, that's at these sampling trees. So this little hose here has got a little fan on it that's pulling air through all those holes. Those holes have to cover 80% of the condensing area. Goes into this little box, which we call a psychrometer. And downstairs, it goes down into a duct into an airflow meter. And both of them have psychrometers. So in the inlet duct and the outlet duct and that outside, you have this little box. It's got a little fan. It's got a little airflow meter sitting in there. You've got two high precision temperature sensors. One of them has a cotton sock that goes down to a little vat of distilled water. So it's nothing more than an automated sling psychrometer. We run 12-hour shifts. Yeah. We run 12-hour shifts, and somebody's arm get really tired in a 12-hour shift if you had to keep measuring that all the time.
Yeah, I bet.
But even today, the most accurate way, most reliable and accurate way to do long-term measurements of moisture content in the air is still a cotton sock on a thermometer.
Isn't that
seems
funny?
Kind of amazing. But, you pay a lot of money to get a 2 or 3% accurate relative humidity sensor, and that's not anywhere close. I can measure wet bulb to, within a thousandth of a degree or something with an RTD. It's very, very accurate. So nice. The only thing that comes close is what they call chilled mirror sensors, where they have a little solid state cooling chip glued to the back of a mirror, and they'll cool that mirror down to a temperature. They're looking for dew point by shining a laser on it. And it's very accurate because you can pick that dew point very accurately, but it cycles on about once a minute. So you only get a reading once a minute. And once it's gone through several cycles, the mirror starts getting dirty and then it drifts off. So, we really haven't come up with a good sensor other than a cotton sock on a thermometer, which it seems very, very old school, but sometimes the old school stuff just works, right?
Yeah, for sure.
But of course now we've got all this into computers and computer racks, and it's all automated. And typically when you're doing this test, you have to stabilize those rooms so that the temperature coming into those coils and the temperature leaving the coil and coming into the unit, leaving the unit, coming into the unit. But the temperatures in the rooms have to be stabilized within half a degree of wet bulb and dry bulb, and you have to hold it there for 30 minutes to be sure you're there. And then you hit the record button and you record once a second for 30 minutes. So it takes an hour to actually do one temperature point, that 175% point or 100% point. Takes an hour to do that. Takes a couple hours to change those rooms and get them that stable. At least as you go into lower and lower temperatures, it even takes longer. So a really good day in the lab with a unit in one of these chambers is 4 data points. I can do an IER in a day if everything goes great, right?
Which happens rarely, I'm sure.
Oh, yeah. So the average in the lab, last time I looked, was like 3.8 data points a day,
Gotcha.
So there's a lot of money that goes in these labs, and it's very painful to do the testing, but that's what it takes to really get accurate readings. But the other thing is these are all very much steady state readings. So I always tell people that I know a whole lot about what our air conditioners do at 4 data points, at 4 weather conditions, basically.
Right.
Outside of that, we don't do a lot of testing because people buy things on EER and IER and SEER, and so we spend a lot of time testing for IER and SEER. They're not buying it on what it does at any point in between.
Yeah.
Or any oddball point. So that's one of the challenges for the future, is to figure out how to predict that and verify that. So like I said, it can take up to 4 hours when you're hitting low temps to get these things stable. So we've got all these test standards, and so people say, well, okay, I'm looking up at, I'm going to put 2 5-ton units on there, or I'm going to put a 10. How do I compare SEER to IER? Well, they're apples and oranges. You really can't compare the two. SEER is really developed based on a residential load profile. Those weighting factors are built assuming that everybody gets up and goes to work at 8 o'clock in the morning, and everybody comes home at 5 o'clock at night. And, so the big load is overnight and not during the day. IER is the opposite. It assumes you show up in the building at 8 o'clock in the morning. And then, so the peak temperature for the day is also going to coincide with the peak occupancy. So the weighting factors affect that. So they're really two different animals. You really can't compare IER and SEER. And then if you start looking at other products, if you look at unitary air-cooled equipment and look at VRF equipment, they both have a rating called IER, but they're not the same rating.
Oh my gosh.
They're not at the same conditions. So the IER for AHRI is 1230, and 1230, basically the coil's always dry on a VRF load test. It's never does any latent load. So most people that do a lot of VRF know that they need a DOAS piece of equipment to go with it, right? Because they really don't do any latent load. But a rooftop unit's it assumes you're doing late load. So they're testing at different test conditions. So the IER may look a lot higher on the VRF than the air conditioner. That doesn't mean it's using that much less energy. It's just different, right? So unfortunately, we don't have good ways to crosstalk this stuff, and we don't use the same standards to talk about both of them. And then water source heat pumps are even more interesting. And all these standards, I mean, DOE has figured this out. The energy advocates have figured it out. They're pushing to try to make them all more reasonable and more, all these standards are being worked on. There's new standards for VRF. There's new standards being worked on for water source heat pumps. But water source heat pumps, I don't know, probably 20 years ago, HRI or the industry decided that we wanted to use the same standard the Europeans are using, because, we live in a world economy. So it'd be nice if we were all using the same test standards. So we adopted this ISO 13256-1
for water source heat pumps.
For water source heat pumps.
Gotcha.
And about the time we got it adopted, the Europeans decided that's not what they were going to test it with. And they built it.
Perfect.
And they changed their regular air conditioning, their equivalent to 210, 240, to accommodate water source heat pumps. So now we got this problem. The U.S. has adopted this 13256 ISO standard, and no one else in the world is using it except us. And ISO is another interesting organization. ISO is International Standards, International Standards Association. That's what ISO stands for. And every country gets a vote. So not every member, not every manufacturer, every country gets a vote. And so because no one else is using this standards, we can never get enough votes at the ISO committee to open up a new standard, because we're the only one using it. Nobody cares. Nobody wants to go sit on a committee for a standard that they're not using.
Right.
So, and they have to be developed internationally. So the U.S., we've decided, HRI in particular said, hey, we've got to develop our own standard. But part of the weird, and this ISO standard was kind of bizarre, it actually backs all the fan energy out of it. It's a refrigeration only standard. And you look at the static pressure and the flow through it, and it does a mathematical calculation of how much energy that should use with the standard fan and you subtract that energy out of what you measure going into the unit.
Gotcha.
So if you have a better than average fan, you actually get more efficiency out of your EER looks even better because you get something measured with even less power than it takes to just run the refrigeration, because you get some credit from having a better than average fan. So if you start looking at it, even if you look at EERs for water source heat pumps and say, oh, well, I'm going to compare it to EER for a rooftop unit or a PTAC unit, they're not the same, because the water source heat pump,
right.
the other ones have fan energy in them. The water source heat pumps don't. So
that's a big deal. I'm glad you brought that up. I forgot about that. So
a lot of people look at this, and you look at these EERs and all these IERs of all this equipment. Well, these water source heat pumps, they're killer machines. They got these, they got this 26 EER. That thing's really kicking. Well, yeah. It's good. I'm not saying they're not good. It's not quite as good as you think it is.
Right. Good point. Yeah.
Good point. So, like I said, going forward, there's constant negotiations. There are new standards being worked on. I'm not working on them anymore. I'm just sitting back and watching. But there's a lot of smart people working on new standards, and so we're going to raise static pressure. There's also some new stuff going on that I have in another talk that we've talked about, where I talked about the future metrics that we might want to go to, where we're looking at ASHRAE 205 data and better models of equipment, and actually being able to model the equipment in the building and get a reasonable answer for how many BTUs per square foot per year the building will use. But for right now,
we're squeezing a lot out of the equipment. I think we're
we're going to max out, at some point we can't just, there's a theoretical maximum that we're going to hit.
That's right.
When we have no delta T to drive across the surfaces anymore, they're so big that there's no delta T across them. We're not going to move any heat. That's just basic thermodynamics.
Right.
So
it costs 3 times as much to get 0.1 efficiency out of it.
Right. So, we're going to hit the point of diminishing returns. In some cases, we're already there. So,
yep, for sure.
So anyway, that was a lot of history. I don't know that there was a lot. I didn't teach you much math, so.
That was great. And that was a lot of good information. A lot of the stuff there I'd forgotten about. So I'm glad you brought it up. And for the viewers, Mark has offered to share these slides. So if you want to email me, my emails, if you're watching this live, just scroll down. My email's down there. If you're watching this in the future on our YouTube channel or podcast, email me and I'll give you my email will be in the show description. So you could just email me there. So, Mark, thanks again, man. You've come on the show and helped us out a bunch. We appreciate you. Any last words for the audience?
No, it's always fun to be on your show, Tony. You always drag stuff out of me that I don't think about.
You're a great guest. I appreciate your wealth of knowledge, and thanks for all you do for the HVAC community as a whole. And I'm glad you dealt with the Washington people, and other people have to do that, because I'm not sure I'd have the patience for that. So
it's actually fun. Everybody, any kind of engineer looks like a rocket scientist when you go up to DC sometimes and you're talking to lawyers.
Yeah, so I get it.
It's a lot of fun, just because you know something more than they do.
For sure. Awesome. Well, thank you, Mark. And just as a goodbye to everybody, thank you for this amazing day. We've had a lot of fun. We blipped out there for a minute, came back on, and I think we got most of our people back on. So that's great. And we'll definitely do this again. This is the 3rd year we've done it. So next year we'll do it again and see how it goes. And so if you need your PDH certificates, just scroll down to the bottom of the screen, or if you're watching this in the future, just email me and I'll get those to you. So we'll close this thing out. We'll play a little more Christmas music on the way out. Courtney and Heather, if you could hang out for a minute. And Mark, thank you so much, and have a Merry Christmas. And I'll see you probably
Merry Christmas to you.
Show.
Yep. And I'm sure I'll see you in Chicago.
All right, buddy. Thank you. Right. Thank you, Mark.
Thank you.